April 14th, 2010. I'm looking for a robots event and it looks like I found it. While the students gather for the robots lab, a little double shot of espresso. Here we go.
So this is the
robots
science building, called as the College of Computing. The second floor is dedicated to the robotics lab, and all the cool projects have been here.
I think we're here.
4D series project of Professor Frank Deller.
That's cool.
Here, move these guys because they're chairs. First link there is our 4D Cities page, which has a little bit of background and movies, and there is a secret door here. This little image, if you click on it, you get a Java applet, which is our 4D Cities demo applet. Creates a 3D model. It doesn't create this in real time. We built this in advance. But instead of just having the 3D model of the city there, you also have a little time slider at the bottom. Okay? And so here, this is a picture from 1967. So if you take the slider and go all the way to 1864, which is when Sherman did his thing here, right? You see that there's way less photographs, and photographs are much older. So here is some Union soldiers breaking up the.
Today, the robot arm was supposed to move a little bit, but we had some image processing algorithm.
Robots with arms and legs and things that can beat the world champion, the World Cup team by 2050. So there's a bunch of different leagues in this. This is a small size league. We have these nice fast little robots that have wheels on them, so it's easy to have them move around. Unlike the big humanoid ones that sort of wobble towards the ball and then flip over it, because that's like a big accomplishment. So this one, the main thing with this is that these robots drive themselves completely. Now, I what we do is we just kind of hit go on a computer and then the robots play soccer. So the way this actually works is there's two cameras, so there's one up there and one up there that can see half the field, and they're telling us where all the robots on the field are. There's these dot patterns on the tops of the robots. The one in the center tells you which team it's on. There's a yellow and blue team, and then the ones around the outside tell you which number robot it is, so we can identify them. And then this computer drives all the robots to actually do things. So I'm going to just show you it.
Holy cow.
Okay, it's for some strange reason has been missing all morning. I don't know why. So yeah, just kick back and go. All right, I guess look at my rolling skills here too. One other little so as far as actually handling the ball, on the front side of the robot, you hear this little roller. There's a roller on the front of the robot that can put a little backspin on the ball, which will keep the ball right against this kicker thing. And there's a bar that's fired by a solenoid that actually kicks the ball. It kicks the ball at about 10 meters per second. So this is actually a very powerful thing here. One big thing with these robots is that everything in here is really completely custom. We can't find parts that do this and do it well enough. So, I mean, you can see we have these OmniDrive wheels here. If everyone wants to come around with the cars. All of these are custom. Yeah. We have to manufacture all of these on site. We have, we're also well beyond. It's cushy.
Yeah, I remember.
Yeah, so far we've generally found that I think there's like one person in the world that we know of that can actually like drive these effectively as well as a computer can, and that guy's a former race car driver. The first student we mentor some of our outreach programs.
Is that something undergraduates can participate into?
Oh yeah, this is like almost all undergraduates. I mean, I'm actually a PhD student, but the majority of all of this is being done by undergrad students.
Okay, robots.
Awesome.
We're also able to give it commands like, say, go to Professor Christensen's office, and it knows where that is, and you can get there after it's built up the map. They call it.
Right, we added that.
Yeah.
We used to run it in balance mode, but if anything went wrong, it would fall over and dispatch everything. So
A lot more dangerous to run it without that. So right now we run it with that. We can take it off, and it will.
Robot systems, but also social animals. And bees are one of the most interesting social animals because they're insects, and in that regard, fairly simple animals. But also they have complex and interesting ways of communication and coordinating. A food source that's 1 kilometer away. Then the number of times she does this is telling the other bees how rich is that food source. So the bees that watch this fly out of the hive, go to that food source. If they think it's great, they come back and do the dance also, and then more bees. And so
I know some of these folks. What's the rest of it? Is this?
It's just Precious, Austin, Matt, and Brooke.
So where's everybody else from?
We're from Boston.
Boston. So you're down from first.
Yes.
Good. I think so far most groups I have been like one large group from one large school, local. So it's good to see we've got the first folks here, and some of these folks are folks that I've been working with for a couple of years. But okay, so good to see you all here. There's going to be several things I'm going to show you here, and it'll researchers and PhD students research. A good part of what I'm going to show you here is stuff being done by undergraduates. These are things that you could be doing a year or two after being here at Georgia Tech. See them working, and you can see the ground station. We've got a couple things happening there on the ground. People down there working, but this is live from this morning. People working. So I wanted to get to the idea. This is not just all kind of like theoretical stuff where people. We actually have people out in the field, and we have undergraduates out in the field doing real interesting robotics things.
Much easier to build than a robot with legs, because when you try to build a leg, you need to deal with lots of joints and things to figure out how it moves. But with and then the result will be it cannot move so fast. But if we have a robot with wheels to our robot, and then we can study more about how the robot can manipulate things like us. So today we are supposed to show how the robot does, because right now the robot is like so it can be like so actually the
arms start moving.
yeah, so that's our picture.
So what's going on here is we have a 3D camera at the top that's giving the location of the pieces.